base region. Also, the width of the base region is very, very
Small.
small. So it cannot accommodate all the electrons of emitter region. So only some electron will flow from here to here. Okay. So these electrons will flow from emitter to base. Current will flow from
Just
here.
emitter.
This is
Sir,
called
what was
base.
the first reason you told?
Listen, and then write. Okay. There is a width of the base region is minimum. Doping level is minimum. So there is not enough space nor enough holes because of low doping level for all the electrons in the emitter region to be accommodated here or to be combined here. So only few electrons are able to flow from emitter to base, and they constitute a very small base current. Remaining electrons have no problem. Once this is forward biased, remaining electrons can flow from emitter to collector. Because this has a wider width, also it has, enough what? Space, right? Yes or no? Plus these supply voltage that you have given has a polarity which is attracting it. Also, this depletion region
Maximum
is
width.
supporting the movement. Okay. So the remaining electron, once this is forward bias, starts flowing from emitter to collector, and that's what causes the collector to emitter current to flow. Now, if you look at the total emitter current, it is actually because of the base current and the collector current. Yes, because the emitter current is caused by the electron flow. Some of the electrons are flowing from emitter to base, remaining electrons are flowing from emitter to collector. So I can write for any BJT, IE is equal to IB plus IC. Always. Doesn't matter which kind of BJT, NPN or PNP. So this is how a BJT works.
What is this voltage we are giving to the base, sir? What is the name? V what?
VBB, VBB, VCC.
Is there any specific name, sir, for that voltage?
You can say mango apple. V mango, V apple. Okay. Doesn't matter. Clear? Is it clear?
Yes, sir, clear.
Hmm. We are not studying 4 years engineering. I am not going to waste a single minute explaining terminologies. You can write whatever you want. Okay. It's very commonsensical to understand. This is base, so we are writing it VVB. It is collector, so we're writing VCC. Okay. Ask some good questions. I'll spend some time explaining it. Clear? Can we move on to next question?
Yes.
Yeah. So this is NPN. Will you be able to discuss, understand PNP on your own, or should I explain? Should I? PNP. What will happen? What will be the charge carrier in emitter?
Holes.
Holes. Holes will be moving from emitter to collector. So current will flow from quick, Baba.
Collector to emitter. Emitter to collector only.
Emitter to collector only. Yesterday कल बता चुका हूँ. So this PN junction has to be forward biased. So what should be the base voltage? Base biasing voltage. Like this. Yes.
Polarity will be reversed, sir. Why is not coming, sir?
प्रॉब्लम हुआ है ना?
और सर का नेटवर्क गया है तो इसलिए वो लॉग आउट हो गए।
Audible?
Yes, sir.
यस सर।
Okay. So in a PNP, what happens? Is it clear? In PNP?
यस।
So PNP may holes will be flowing from emitter to base, and remaining holes will be flowing from emitter to
कलेक्ट।
collector. This will be the biasing voltage. Okay, draw it properly. Clear? ठीक है? Same logic, just nature of charge carriers are changing. Now, based on this, you need to now we'll be drawing the electrical symbol for the BJT. This is how you represent a BJT. You will always find an arrow at one of the terminals. So the arrow can be here like this, or the arrow can be like this. Okay. So wherever is that arrow, that is your emitter, no doubt about it. If you see an arrow in the BJT symbol, that is your emitter. This will always be base. Then the third one will be collector. Okay. Now this is how you represent a transistor. Now which is NPN, which is PNP. Now if you look at the NPN or a PNP transistor, what did we see? Current is always flowing at the emitter base junction from where to where? P to N. Why? Because emitter base junction is
फॉरवर्ड।
forward biased always. Whether it is NPN transistor or PNP transistor, we are forward biasing the PN junction. So the current is always going to flow from P to N. Yes. So this can be, an indication of the sign. So if you see a sign, this is basically showing you the direction of current. So you can easily say which is P, which is N here. This is emitter base junction. This is emitter base junction. Which is P, which is N. Can I say this is P, this is N? This is P, this is N. Because current is always flowing from P to N. So this becomes NP, N, P, N, P. So if this kind of an arrow is drawn, it is PNP. If this kind of an arrow is drawn, it is NPN. Now, let me ask you a question. Which kind of a transistor this is?
PNP।
PNP.
Okay, so understood. Now I will draw the biasing circuit which we draw earlier. Now you will be representing the BJT like this only. Okay, so this is the biasing circuit. If you bias it, current will flow from collector to emitter. When you apply, we say positive, this is called as positive base current. Okay, and what is this called as? What is this called as? This is called as negative
Negative base current.
Base current. You can remember it like this. Here the base is, you know, connected to positive terminal or has positive voltage with respect to emitter. Here the base is having negative potential with respect to emitter. So we call it negative. Or you can remember it as current coming out of the base is negative, current going inside the base is positive. So if in case of a PNP, NPN transistor, if you apply positive base current, what will happen? Current will flow from collector to emitter. How much current will flow from collector to emitter? Depends on how much you give
Base current.
base current. So this graph we can actually draw. Here also current will flow from emitter to collector if you apply negative base current. How much current from emitter to collector? Again, it will be determined by how much you give the base current. You can control the base current by controlling this resistance. Okay, just like in a diode, you are able to control, no? Yes or no? By changing the voltage or the resistance. Can you control the current through a diode in a circuit? You remember from yesterday?
Yes.
If I, let's say, give 5 volt and this resistance I keep changing, will the current in the circuit not change? It will, right? So similarly, this when we change, the voltage here changes and it changes the current. Okay, base current. Base current changes, collector to emitter current will also change. As I told you, it is like a tap. देखो टैप में ऐसा पाइप में हमेशा पानी रहता है, ठीक है, लेकिन पाइप से पानी आप कितना निकाल रहे हो टैप के थ्रू, दैट डिटरमाइंड बाय आपने टैप को कितना खोला है. तो उसी तरह है, बेस करंट इज लाइक अ ओपनिंग और क्लोजिंग द टैप. If you give more current, more conduction or flow will happen. If you reduce it, less conduction will happen. So you can control the operation or conduction of the BJT by using this base current. So that's why this BJT is called as current control semiconductor device. Clear? Now इसका ग्राफ भी देख लेते हैं, because we are doing it. Let's finish the graph also. Then we'll discuss thyristors. Is it okay if we discuss MOSFET and BJT tomorrow? Because I want to cover synchronous motors and starters today. Is it okay?
Sir, after like same time से 7 p.m. is okay sir.
Sorry?
7 p.m. सर, because कल रिटर्न भी है सर, तो 7 p.m. के बाद अपन रहेंगे अवेलेबल.
No, no, I'm asking right now. Is it okay if I cover IGBT MOSFET tomorrow?
Yes, sir. Yes,
Okay
sir.
sir.
Yes,
Okay,
sir.
I will only finish
Yes.
because some those topics are pending, starter topic and this, so I want to cover it and finish it. Also, alternator protection is left. We need to start. So I'll only cover SCR today, and then we'll discuss starters. Soft starter. Have we discussed? No, I don't think so. Okay, so sorry.
Soft starter बाकी है अभी.
We'll do it. We'll do it today. So this is VCE. This is VCE. And this is IC. Okay, so I'm drawing this characteristic, current versus voltage characteristic. See, if there is no current flowing through the BJT, can I say VCE is equal to VCC? Just see. If there is no current flowing here, that means there is no drop here, right? Yes or no? There is no drop ICRC. So whatever is the voltage that you apply here, same will be the voltage at VCE. Yes?
Yes,
Yes.
sir.
Yes. So what happens if you do not give any base current? Will there be any current flowing through the circuit?
No, sir.
No
No.
sir.
Can I draw a line like this and say this is my characteristic for IB equal to 0?
Yes sir.
Yes, because IC is 0. At IC equal to 0, VCE will be equal to
VCC.
VCC. So this can be this can be also your supply voltage. Please remember this. Yes. What is VCE? All these points are actually VCC. Okay. So even if you keep on increasing this, VCE will increase, but there will not be any current flowing in the circuit. Why? Because we have made the
No
base
base current.
0. Now what we do? Now we apply some base current by adjusting this RB. Let's say I am giving 10 microampere. So this is fixed. Now what I do, please listen to me carefully. Do not write. This is very important. We do not have time. See, it's not like I want to go very fast. If I had time, I would teach you in 3-4 months. We do not have time. We have just 10-12 days in which we have to cover a lot of syllabus. So please do what I am telling you. Listen carefully, and then if you want to write, you write. Okay? I'll not be able to repeat. So if this base current I'm keeping it fixed, can I keep it fixed by adjusting this RB? Yes, we can.
Yes.
So if we keep it fixed, now I am changing this VCC. VCC is nothing but VCE when IB is 0. Yes.
Yes, sir.
So if I now increase VCC, what will happen to the collector current? Initially, it will increase with voltage. समझ में आ रहा है? As this voltage increases, this VCC increases, collector current will increase, but it will not increase beyond a point. Even if you keep on increasing VCC, VCE will increase, but collector current will not increase for a particular value of what?
IB.
IB1. If your IB1 is fixed, it will reach a particular value and then it will stop.
Okay.
This is called IC1 equal to beta IB1. Beta is called current gain. Okay. Now, if you want to increase the current again, IC current, collector current again, you have to increase base current. How will you increase?
Using the
By
RB.
adjusting the
Changing
RB,
the resistance.
changing the resistance. If you further increase, again it will rise to a new value, but again it will saturate. And even if you change the supply voltage, it
VCC.
will not change. It will again saturate. Like this, you keep on doing. This is what is happening. Okay. We are not going in detail of why it is happening, how it is happening. Okay. We can explain all this. We don't have time. Okay. Is it clear? So
Yes, sir.
Yes, sir.
you are increasing IB like this. All right. So every time you increase, it goes to a new saturated value. Now, this region where you are not getting any what? Conduction is called as cutoff region. Okay. This region is called saturation region. Sorry for the spelling. And this region is called active region. So a BJT can operate in 3 regions. Okay, what are the 3 regions? Saturation region, cutoff region and active region. Now BJT का 3 एप्लीकेशन है, ठीक है? 3 एप्लीकेशन नहीं, मेजरली 2 एप्लीकेशन है, एक एम्पलीफायर एंड एक ऑसिलेटर, बट इट कैन ऑल्सो एक्ट एज अ switch. So if you want to operate the BJT as a switch, you toggle the BJT in these 2 regions. Which 2 regions?
Cutoff and active.
Cutoff and saturation. So in cutoff, it acts as a off switch. Off switch matlab
Open
switch, open switch. And in saturation, it acts as a on switch. That means closed. If you want to operate the device amplifier BJT as an amplifier, you keep the operating point in active region. So for that, you have to bias the BJT in the active region. So what do you mean by bias the BJT in active region? Cutoff region means both the emitter base and collector base junction are reverse biased. Okay. Saturation region mean ये पूछता है, ठीक है, इलेक्ट्रॉनिक्स में both emitter base and collector base regions are forward bias, and active region means emitter base junction is forward bias and collector base junction is reverse bias. Now you will ask ये कैसे हो गया? अभी तो मैंने ये देखो, ये तो हमेशा फॉरवर्ड बायस ही रहेगा, है कि नहीं? ये तो फॉरवर्ड बायस है, ये कहाँ से मेरा रिवर्स बायस हो गया? ठीक है, सो दिस इज द डीसी बायसिंग सर्किट. In DC biasing circuit, you always connect the supplies in such a way that your emitter base junction is forward bias and collector base junction is reverse bias. Okay, so if you see this, let's say this is 12 volt. Can I say this is at 12 volt and this is at 0? Can I say?
Yes,
If there is no current, and let's say this is 2 volt. So if this is at 2 volt plus 2 volt, let's say that no current is flowing, and this is at 12 volt, the collector base junction is forward bias or reverse bias? Your P is at 2 volt, your N is at 12 volt. Is it forward bias or reverse bias?
Reverse.
Reverse bias.
Reverse bias.
This is plus 2 volt, this is 0 volt. The emitter base junction is forward bias or reverse bias?
forward bias.
Forward bias.
Forward bias. So this is what is called DC biasing circuit. So when you DC bias the circuit, this is how you bias it always. These reasons are when you actually connect the signal. See, this has to act as an amplifier. So you have to give the signal, right? है कि नहीं? तो सिग्नल आप कैसे देते हो वो हम लोग देखेंगे, ठीक है? तो I have only shown you DC biasing circuit. You note down these things. We'll discuss. When we discuss amplifiers, I'll explain you how we give signal to this DC biasing circuit to amplify a signal. Amplify means what? What do you call as an amplifier? बताओ. What do you mean by amplifier? Hmm?
Increase in
Amplify or increase.
waveform.
Increase what?
Amplitude of the waveform.
That your transformer is also doing. That a transformer can also do. If you have a step-up transformer, does it not increase the RMS value?
Yes, sir.
So, do you mean to say that step-up transformer and amplifier are same? ये क्वेश्चन पूछा भी था. What is the difference between amplifier and transformer?
Sir, physical separation.
Physical separation what? So amplifier, you can write down, amplifier is a electronic circuit which increases the amplitude of a signal, okay, without changing its frequency. So frequency, faithful amplification need to be done. Faithful amplification मतलब amplifier commonly आप कहाँ पे देखते हो? स्पीकर्स वगैरह में यूज होता है, राइट? जो कोई माइक्रोफोन से बोल रहा है और लाउड स्पीकर्स लगे हुए हैं, तो लाउड स्पीकर को आउटपुट कहाँ से जा रहा है?
Amplifiers.
एम्पलीफायर से जा रहा है. तो एम्पलीफायर इज बूस्टिंग द microphone is converting your voice signal into electrical signal, and electrical signal is fed as an input to the amplifier. और एम्पलीफायर क्या आउटपुट करता है? उसका एम्पलीट्यूड इंक्रीज करके आउटपुट करता है. without changing the frequency. और ये increased amplitude का signal loudspeaker में fed होता है और loudspeaker will give it to larger audience जो कि सुन रहा है. ठीक है, यही हो रहा है ना. तो एम्पलीफायर में मान लो आपने एक इनपुट दिया, तो वो इनपुट क्या होगा? 2 टर्मिनल से ही दोगे, राइट?
Yes.
और जब आउटपुट लोगे तब भी आप 2 टर्मिनल से ही लोगे. तो टोटल कितना टर्मिनल्स चाहिए या फॉर एम्पलीफायर टू वर्क?
4 terminals.
4 terminals. All right. So you are giving a signal here of, let's say, frequency 60 hertz. If you get a frequency of 100 hertz, is it a good amplifier?
No, sir.
No,
No. यहाँ पे आप बोल रहे हो, यहाँ पे मान लो कौन है? Let's take an example. Let's say here you have Aditya. Aditya is speaking here, and here the voice of Aditi is coming. Then what will happen? I'm just joking. Okay. What is happening? If a person is, if a man is speaking here and here a girl voice is coming, that
Pitch
means
is
what has
increasing, so sound pitch is increasing.
so pitch has changed. If pitch has changed, that means what? Frequency has changed. That means आपका amplifier ढंग से काम नहीं कर रहा है. It is not doing faithful
Amplification.
amplification. तो इस पे क्वेश्चन पूछ दिया था. What is faithful amplification? ठीक है. So we will discuss this. ठीक है. So the important thing is the frequency should not change. It should keep it as much as the same as what we are giving as input. So to do amplification, you need 4 terminals. This is called as input port. This is called as output port. Each port should have 2 terminals. But BJT has how many terminals?
3.
3. So one terminal has to act as a
Round.
common terminal. So you have emitter, you have base, you have collector. So base terminal can act as a common terminal. Possible? Possible, no. You give input from here and you take
Yes, sir.
output from here. So this kind of amplifier is called common
Yes.
base amplifier. Similarly, your emitter can also act as a common terminal. That means it is a part of input as well as output port. So that is called as common emitter amplifier. Similarly, your collector can also be.
Common collector amplifier.
So there are these 3 kinds of amplifier which can be configured using a BJT. Okay. In this regard, you have the current gain defined for these 3 transformer. इसको बोलते हैं, इसका current gain को बोलते हैं अल्फा, इसके current gain को बोलते हैं बीटा, इसके current gain को बोलते हैं गामा. तो ये भी क्वेश्चन पूछा था, what is alpha, beta, gamma in the context of BJT. So they are the current gain of respectively common base, common collector, common emitter, common collector amplifier. So we'll discuss this also. ठीक है. But did you understand how to identify BJT if your symbol is given?
Yes, sir.
Yes. So next class tomorrow we'll finish this amplifier also along with IGBT and MOSFET. Let's discuss the next device, which is Thyristor. So what is a Thyristor? Thyristor is a 4-layered semiconductor device, a family of 4-layered actually. It is not any particular device. It's a family of 4-layered semiconductor devices. That means, and they have some properties. So one of the important and most commonly used thyristor on board is SCR. What is the full form of SCR?
Silicon control rectifier.
Silicon controlled rectifier. Okay, so I'm going to draw the cell structure. PN. How many terminals SCR has? 3 terminals: anode, cathode, and gate. How many junctions it has? 3 junctions. Okay. What type of device it is? It is again unidirectional device, just like diode, and it is current controlled. Apart from this, it is also a latchable device. What is a latchable device? See, in a BJT, if I remove the base current, will it conduct?
No, sir.
No, sir.
In a
No, sir.
SCR, if you remove the gate current, it will keep on conducting if you maintain some condition. So in that context, we are saying that it is a latchable device. It can get latched or locked into a conducting state. Okay, so we'll discuss it. Now, there are two ways to understand this SCR. One way is we understand it like a diode. These junctions we can see whether they are forward bias or reverse bias and try to see what is happening. But there is a much easier way, and we will use that model. So that model is a transistor model. In a transistor model, we see these 4-layer semiconductor devices as combination of two what? BJTs. We can see it as a PNP and a NPN BJT. Can I represent this 4-layered as like this? Is it possible? Just see. Can I draw like this? Just check. Can I?
Yes.
Yes, sir.
Now it's your job to tell me in this PNP transistor, which is emitter, which is base, and which is collector. Okay. Yes.
Base is the gate, sir.
This is the base. Base is not gate. This is base. No doubt about it. Middle region is always the base. Just tell me which is emitter, which is collector here. See, one thing is just like diode, let me tell you so that it becomes easy for you. A SCR will conduct or will turn on when you establish these two conditions. This is called as gate triggering. This method of starting the SCR or making the SCR conduct is called gate triggering method. In gate triggering method, what do? We first forward bias the SCR just like a diode. But just forward biasing the SCR will not make it conducting. Is it forward bias? Just see right now.
Yes.
Yes, anode is connected to more higher potential than cathode. So it is forward bias. Will it make it conduct? Answer is no, not normally. We'll see a condition when we can make it conduct only by forward biasing it. But right now, not at a normal voltage, it will conduct. First, you have to forward bias, and then while it is forward bias, you have to apply,
Gate current.
Gate current.
and that gate current should be positive gate current. And it can be a pulse. It need not be a continuous current. Why?
It is a latching device.
Because it's a latchable device, not a latching device. Okay, it's a latchable device. It can get locked into conduction mode. So this is clear. So this we have forward bias. It tell me if it conducts, the current will be always flowing from this direction to this direction only, right? Yes or no?
Yes, sir.
So now based on that, you tell me which is this P. In a PNP transistor, current enters through which terminal? Emitter or collector? Go back to your notes and tell me.
Emitter.
Really, emitter. In a PNP transistor, current enters the BJT from which terminal?
Emitter, sir.
Emitter, sir.
Emitter. And so this is your emitter, correct? And in a NPN transistor, current leaves through which terminal?
Emitter.
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 So this is a shortcut. Even if you don't want to think about all this, you just remember anode is an emitter, cathode is also a emitter. Okay? If you are explaining the SCR using transistor model. तो आपको SCR समझाने के लिए बोलेगा आपको फट से ये बनाना है. तो ये क्या होगा? ये कौन सा टर्मिनल है?
Collector. Collector.
Either you can mug it up or you can understand it. It's your choice. I'll leave it to you. Now you will not draw this model. You have to use symbols. So how do we draw the symbols? ठीक है? Is it correct? Anode, cathode, supply voltage, load. I can call this as a Q1 and this transistor as Q2. Now you need to explain how it is conducting. Is this clear? You should not draw this. You have to draw this. I draw it only to explain you. Okay? So you can directly draw this and explain how a SCR works. So this is the SCR. I am going to draw the symbol of SCR. It's just like a diode, okay? You can draw a line here to represent the gate terminal. Okay, this whole thing can be drawn like with a represented like this. So this is which terminal? Anode, cathode, and gate. This is the most important device which will be used many times in your different circuits. So it's important you understand it properly. Can I rub this?
Yes.
Okay, tell me, let's say I'm not giving the gate pulse. Will it conduct?
No, sir.
No, sir.
Yes, sir.
How?
सर आपने बताया अभी जैसे कंडीशन कि
मैंने
ये
बताया
Forward bias.
मैंने बताया आपको आता है या नहीं आता है उस पर बोलो.
नहीं सर नहीं सर नहीं
नहीं,
बोलिए।
नहीं आता है. तो आप वो कंडीशन वो मेथड हम लोग यूज करते भी नहीं है. ठीक है, वो मेथड आपके शिपिंग के किसी भी सर्किट में नहीं आएगा. ठीक है, तो उसके बारे में आपको बस पता होना चाहिए ऐसा मेथड है, लेकिन कहीं ये यूज नहीं होता है आपके जो भी सर्किट्स आपको पढ़ना है. तो एज अ मेथड आपको दिमाग में होना चाहिए. यू विल नॉट बी टॉकिंग अबाउट इट. ओके, नॉर्मली वी आर यूजिंग विच मेथड?
Gate triggered.
Gate triggering method to turn on the SCR. In this method, we first forward bias the SCR and then we apply positive gate current pulse. I am not giving the gate current pulse. I am not giving this gate current pulse. Is my device SCR going to conduct?
No, sir.
No. Explain why no. Why no? Current can come from here, no? What is stopping the current? By the way, the current that the SCR conducts is called anode current. What is stopping this current from flowing? Can you tell me?
सर
There is no base current, sir, to make it
बेस
conduct.
करंट नहीं है सर.
हाँ वो ठीक है, अभी बीजेटी के बेसिस पे बताओ. See, if these two BJTs work, Q1, Q2 conduct, will the SCR conduct? Right? If these two conducts, SCR will conduct, no?
Yes, sir.
Yes.
sir.
So if I show you that these two cannot conduct without a gate current, does it also prove that without gate current, SCR cannot conduct? Right?
Yes, sir.
Yes, sir.
Yes.
See, If this current is coming here, we already know this is an emitter current, so it can break it up into base current and collector current, right? This collector current can provide the base current for this. Yes? Yes. So this can conduct, no? What's the problem? What's the problem? Why it is not happening? Why it is not happening is, please pay attention. For this base current to flow, this collector current path should be there, right? If there is no path for collector current to flow, will base current flow? Tell me.
No, sir.
No, sir.
No. So unless Q2 starts conducting on its own, can Q1 conduct before it? Just
No,
think.
sir.
See, for Q2 to conduct, we need a base current. That base current can come from two directions, either this direction or this direction, right? Yes.
Yes.
I am not giving this. Can it come from here?
No, sir.
No. Why? For this to come, for this to flow, this should flow first, right? This is a NPN transistor.
Yes, sir.
Only when a PNP transistor. Only when this negative base current flows, emitter to collector current will flow. This collector current will supply the positive base current. This will make the Q2 conducting. But I am not giving the gate current. There is no way Q2 can conduct before Q1. Yes or no?
Yes, sir.
Yes. Only when we give the gate current, what will happen? This gate current will flow as a base current, will make this conducting. Now you have your base current can flow as collector current, and then this will start conducting. And when this starts conducting, this can supply your base current. So you can stop your.
Gate current.
Current.
So that's why we say, let's say this is representing your IG. IG was 0. You gave the gate current, but the moment you give the gate current, what happens? Q2 starts. Q2 is ready to conduct. So Q1 starts drawing emitter current. One part of it flows as a base current, and this base current starts flowing as a collector current here. This remaining of the emitter current or anode current will flow as collector current and will supply the base current. That is what is making the circuit, making the SCR
Latch.
latchable. It is a latchable device. Clear?
सर ये लैचेबल वाला बता दिए एक बार लैचेबल के
Latchable matlab I do not need to supply the gate current continuously. I can give for some time and then stop. The moment collector current starts flowing from this Q1, this will supply the base current and keep the device latched or conducting.
ओके
Now let's draw this graph. So this is how you turn on the SCR. Now this base current has to reach some minimum value before it can start conducting, correct? Yes or no? If the device is in cutoff region, that means you have a base current which is, you need some minimum base current, right? Then only this, BJT
will
will
start conducting.
So if you need a minimum base current, can I say you need some minimum anode current for conduction to begin?
Yes, sir.
Because this base current is coming from here only. So the anode current must cross some minimum value before the SCR gets latched or gets conducting. So this minimum anode current is called latching current. Okay, so we'll draw the graph now. See, if the device is off, can I say VAK is equal to VS? If the device is off, SCR is off, can I say VAK, anode to cathode voltage, is equal to VS? Because there is no current here. There is no.
Yes, sir.
So this, can I draw this line and say this is representing the supply voltage, VAK equal to VS? IA is 0. If IA is 0, can I also say this VAK line is representing the supply voltage? All these are supply voltages, can I say?
Yes, sir.
Yes. Now let's say at any one of these supply voltages, I apply now the positive base current, sorry, gate current. Let's say I apply some positive gate current at this supply voltage. So what happens? Current will start increasing. Let's say anode current is at this point. Is the device conducting? Is the device conducting? Yes, no.
Yes, sir.
No, it is not. Because VAK is still equal to the same supply voltage. Yes or no? At any point on this line, is supply voltage and VAK same? Same or not same?
Same, sir.
Same. If only if VAK becomes 0, we can say the device is truly conducting, or it drops, we can say it is conducting. Yes or no? When it is equal to supply voltage, how can we say it is conducting? Yes or no? So the voltage drop has to happen, and that happens when the anode current crosses a minimum value. So this value is called latching current. The moment the anode current crosses the latching current, there will be a voltage drop happening across the what? SCR.
Ammeter.
So it will jump directly from here to this point. And then there will be some basic drop. Okay. Let's say this is happening at IG1. Is this clear to you? So all this point, is the SCR conducting? All this point here? No, it is off. The moment it crosses, anode current crosses the latching current, what happens? Divide gets on and there is a significant voltage drop across the VAK. Rest of the voltage appears across the load. So I can say the SCR is acting as a closed switch. Clear? Now I can on the SCR at a higher supply voltage. Possible? Very much possible. Let's say this is IG2. Then the same thing will happen as the latching current, crosses, it will start conducting. Same thing we can do at IG3, okay, at higher, a little higher voltage, supply voltage. Like this, you can keep on going on, which is found that IG1 is greater than IG2 is greater than IG3, like this. So what are we observing in SCR? As the supply voltage increases, the gate current needed to latch the device. Bolo.
Also increases, also decreases.
Is
Increase
it
होगा
clear?
ना?
It is decreasing. Is it clear?
Yes, sir, decreasing with.
Increase होगा ये कहाँ से आपने पढ़ लिया? मैं बोल
नहीं
रहा
सर,
हूँ
मैं उल्टा बोल दिया सर, मैं डिक्रीज बोल रहा था.
डिक्रीज होगा. ठीक है. कैसे हो रहा है उसके डिटेल में हम लोग नहीं जा रहे हैं. ओके, वी डू नॉट हैव टाइम. This is what it is. This is how it happens. We need to use the device and not go into too much detail of it. ठीक है? क्लियर है इतना?
यस सर.
इतना क्लियर है? नहीं नहीं, आप जब तक पूरा नहीं बताओगे हम लोग सिलेबस कंप्लीट नहीं मानेंगे. आप नहीं मान सकते हो, लेकिन वो पूरा बताने में 6 महीने लगेंगे. ओके, इतना आपके लिए काफ़ी है. ठीक है, अगर आपको इंटरेस्ट है तो एग्जाम पास कर लो आप पहले, उसके बाद यू कैन कीप रीडिंग. ठीक है, इससे ज़्यादा आपसे नहीं पूछेगा. इज इट क्लियर? नाउ
Yes.
if you keep on increasing the supply voltage, followed by supply voltage, a point will come. This is called as forward breakover voltage, at which the gate current required will be 0. So if you give this much forward bias voltage, which is equal to what? Forward breakover voltage. Then the gate current required is 0 and the device will be latched without any gate current. Is it clear? We are not discussing this method. This method of starting a SCR is called what? Forward voltage triggering. So if they ask you what are the different methods of starting a SCR, this is one of the methods. We are not using it, so we'll not be studying it also. Is the graph clear to you? You don't need to draw all this. You can show it for one gate current, or you can show it all also. It's all okay. Okay. So what you need to do to turn on SCR, you need to make the current flowing through the SCR cross latching current. Is it clear? How do you define latching current? It is the minimum anode current which must flow through the SCR in order to latch it or turn it on. तो ये minimum anode current है, इसको तो cross करना ही करना है. Why it is there? This model is basically telling you why it is there. Because you require some minimum base current here to latch the circuit or device. Clear? Now please do not consider this two BJTs like let's buy two BJTs, connect it like this, I will have a IGBT. Sorry, I will have a SCR. No, this is a model. समझ में आया? ये एक मॉडल है. वो आपने देखा है ना, पाइप में प्रेशर के थ्रू एक्सप्लेन करते हैं रेजिस्टेंस, देखा है?
सर
आपने पढ़ा होगा ना, ओम्स लॉ बताने के लिए पाइप में प्रेशर यूज करते हैं, पाइप वाला एक एनालॉजी यूज करते हैं, मॉडल यूज करते हैं. पढ़ा होगा आपने इलेक्ट्रिकल समझने के लिए. तो
Yes,
वो
sir.
एक मॉडल
हाँ
है.
तो बचपन में पढ़ा था सर.
हाँ, तो वो एक मॉडल है. मॉडल का मतलब क्या है? We are using it as an example to understand. Similarly, this is just as a model. It will not explain all the characteristics of the SCR, but it is giving you a fair understanding of how a SCR works. Okay? We will not be able to understand everything from this model, but this is a good enough model to understand some characteristics of SCR. Okay? Similarly, how to turn off an SCR? Is turning on SCR clear? Very simple.
Yes, sir.
Forward
Yes,
bias
sir.
it. While it is forward bias, give positive gate current pulse. How to turn off an SCR? You can turn off an SCR very easily by reverse biasing the SCR. This is the most common method. In DC circuit, you need to use a circuit which is called as force commutation circuit. If you want to reverse bias the SCR and turn it off, if the SCR is a part of DC circuit, then you have to use a method called as forced commutation, which will not be studying because you will always be using SCR in
Yes.
Powered by.
AC circuit. In AC circuit, do you need to do anything?
No sir.
No. If you apply AC, automatically it will reverse bias it every half cycle. Yes. So in AC
Yes,
circuit, natural commutation will happen and you don't need to reverse bias it. It will automatically reverse bias it and turn it off. So every new forward bias cycle or a positive half cycle, you have to apply positive gate current pulse. So for this, you need a gate triggering circuit. In all the recent, circuits which you will be studying, soft starter, AVR, we are using a microprocessor or a microcontroller which has a program inside which is generating the gate signals. Okay, but there are other gate triggering circuits also. If time permits, we will discuss. Clear? Now, so if you have to reverse bias the SCR, that means the moment you reverse bias it, current will start falling down. If it falls below what is called as holding current. If it falls below, I will send you a proper graph also. If it falls below what is called as holding current, the SCR will turn off. So the current through the SCR must fall below holding current while you are reverse biasing it to turn it off. If the current is between latching and holding while you are trying to turn it off, will you call it in conducting or not conducting? Current is between latching and holding while you are turning it off. Is it conducting, not conducting?
Conducting, sir.
Current is between holding and latching current while you are turning it on. Is it conducting, not conducting?
Sir, not conducting, sir.
Clear?
Yes, sir.
While turning on, the current should cross latching. While turning off, it must fall below
Holding current.
Holding current.
Name itself is telling you it is holding the device from turning off. If the current falls below it, it will turn off. Its characteristic is similar to a diode. When you reverse it, there is a reverse breakdown potential. If you give more potential than that, it will lead to avalanche breakdown and get damaged. There is a leakage current also flowing in the reverse direction. Okay, clear? So this is the characteristic of a SCR. Now let's discuss soft starter. Shall we discuss?
Yes.
Symbol of SCR is clear.
सर DOL और ऑटो ट्रांसफार्मर हो गया क्या?
नहीं हुआ है. DOL हो गया. ऑटो
हो गया, ऑटो नहीं हुआ, सर.
ऑटो नहीं हुआ है. ऑटो ट्रांसफार्मर इज लेफ्ट. विल डिस्कस इट टुडे. देखते हैं, विल सी. नहीं तो कल भी डिस्कस कर सकते. आई थिंक विल फिनिश
स्टार डेल्टा भी बचा हुआ है सर.
या स्टार डेल्टा ही बचा हुआ है. आई थिंक एक बैच के लिए बचा हुआ है. एक बैच के लिए हो गया इधर, है ना?
हाँ सर, अपना हो गया, सर.
सर DOL एक बार फिर से करा देंगे. मैं सर क्लास में अभी जो लेट ज्वाइन कर.
देखेंगे देखेंगे अगर हो पाएगा तो कराएंगे. अभी सॉफ्ट स्टार्टर देखते हैं. ठीक है. दिस इज योर सिंबल फॉर SCR. व्हाट इज द फुल फॉर्म ऑफ SCR?
सिलिकॉन कंट्रोल रेक्टिफायर.
So first let's look at the rectifier circuit. Rectifier circuit means the diode rectifier circuit. So rectifier का मतलब क्या हुआ? A
Diode, sir.
circuit which can convert AC into
DC.
DC. So already you have a diode. It can act as a rectifier, right?
Yes, sir.
So you give some input at a certain frequency. The output that you will be getting here is the DC. We'll see how. So this is your diode. Okay, this is the input that you are giving. This is your input voltage. Now, from yesterday class, we discussed that if you forward bias the diode, what will happen? It will conduct. So from this time to this time, is the diode forward biased?
Yes.
Yes.
It is. So it should conduct, but will it conduct at 0 voltage?
No, sir. After
No,
that
sir.
potential voltage.
After how what? After what voltage?
Barrier voltage.
Barrier potential. If you give more than the barrier potential, then only it will conduct. Let's say this is the barrier potential voltage, 0.7. So the diode will start conducting only at this time and it will stop conducting at this point. Yes?
Yes, sir.
Let's say this is the phase angle, theta. So can I say it will conduct only between theta 1 and theta 2
Yes, sir.
and not anywhere else? Again, it will start conducting theta 1 and theta 2. Just see this and tell.
Yes, sir.
So what will be the output? I ask you, draw the output. Can I say from 0 degree to theta 1, there is no conduction?
Yes, sir.
At theta 1, what will be the voltage output? 0?
VB.
Zero, not VB.
Yes, sir. 0.
Because this is VB, this is VB. Yes. When this reaches 0.7, this is 0.7, right? So here will be 0. Yes. 0. The peak is let's say VM. When this reaches VM, what will be the about output voltage?
So VM minus VB.
VM minus 0.7.
So when this reaches VM, this reaches
VM minus 0.7.
gain at theta 1, theta 2, it will conduct. Will it conduct in the reverse direction?
No, sir.
No
No,
conduction,
sir.
output. Again like this. समझ में आ रहा है output? But this is not the output you have seen in your books. Yes, what is the output you have seen?
Halfway पूरा.
तो ये जो आउटपुट आप देखते हो ये आइडियल डायोड के लिए आउटपुट दे रहा है. आइडियल डायोड मीन्स बैरियर पोटेंशियल इक्वल टू
0.
0.
0 वोल्ट. तो आप ऐसा भी बना सकते हो, लेकिन आपको पता होना चाहिए आप जो बना रहे हो किसके लिए है. ठीक है. तो इन दैट केस दिस विल बी VM. ओके. Actual, this is the actual output. If you consider the barrier potential. Now, either you can draw this or you can draw this. You should be ready to handle question. That's what I'm saying. If you draw this, surveyor will ask you why you have drawn this strange kind of graph. If you are able to explain, good. Actually, very, very good. But if you are not able to explain, you are inviting troubles. If you draw this and surveyor asks you how it is you got this, and you are not able to explain, then also you are inviting trouble. Okay. So you are not going to be escaping from trouble if the surveyor decides to fail you. Only thing which can save you is knowing both the things and understanding when to say what. Okay. So you can answer it like this also. I can answer it like this also. It's your choice what you choose. Okay. But for the output, I will be using this to give you the DC output voltage. So this is a DC output, right? Current is going to be unidirectional only, right? So this is a DC output. If I connect a multimeter or a clamp meter and measure the, not clamp meter, if I measure the volt using a multimeter, this voltage, how much voltage will it give? Yes.
VM by 2 root 2.
VM by pi.
VM by 2 root 2. No, it will not. It will give us the average value in one cycle. So average value in one cycle is how much? 0 to 2 pi Vm sin theta d theta, 0 to 2 pi d theta. Yes. Yes or no?
Yes, sir.
So pi to 2 pi is 0. So I can only integrate from 0 to pi. This will be 2 pi. Now you integrate it and tell me what is the answer. If you integrate sin theta, what will you get? Minus cos theta.
Minus.
Now you do this, what will you get? What will you get?
VM by pi.
You will get Vm by pi. So what is the output if you measure here? If I give you, let's say 5 volt AC, 60 hertz AC, how much output you will get? Can somebody calculate? And this could be a written question also. 5 volt 60 hertz AC you are giving, your diode is there, calculate the output voltage. नहीं तो यहाँ हटा के एक बैटरी लगा देगा. ये क्वेश्चन पूछा भी है. क्लास 2 के रिटर्न्स में ये क्वेश्चन आया हुआ है. यहाँ पे एक रजिस्टर लगा दिया, यहाँ पे एक बैटरी लगा दिया. चार्जिंग सर्किट हो गया ना? नहीं. चार्जिंग
2.2 volt.
यहाँ बताओ कितना हो रहा है, कितना वोल्टेज जाएगा? 2.2 volt is saying. I am taking ideal diode and asking you a question. What will be the voltage output here? DC voltage output. 2.2 volt he is saying. Is it 2.2 volt? Vm upon pi. What is Vm?
5 into root 2.
Divided by pi.
Yes, sir.
How much you are getting? You calculate. Okay, clear? Can I rub this?
तो 2.25 ही आ रहा है सर.
ठीक है, आ रहा है तो अच्छा.
2.25.
This is half wave rectifier. Why it is called half wave rectifier? It is converting only one half of the full cycle of AC into DC. So this circuit, a circuit with a diode is called, a single diode is called half wave rectifier. Now I will only discuss the ideal diode case. You already know what will happen. Now let's look at full wave rectifier. How does it work? So full wave rectifier can be two types. One can use a center tap transformer, which is like this. You can give a AC to a transformer with a center tap. What is a center tap? Center tap has three terminals. Two terminals of normal, two terminals of secondary winding, and another terminal going from the center of the secondary winding. Okay. The turns ratio of the center tap transformer is 1:2, and you connect two diodes like this. And this is where you get the output. So for simplicity, I am connecting a load here just to show you how the current is flowing. D1, D2. You are giving some input voltage. Okay. Let's say the input voltage is at this point. At time t1, let's say this is 2 volt. If this is 2 volt, what will be the voltage here? Induced.
2 volt.
2 volt. What will be the voltage induced here?
4 volt.
4 volt. Yes. What will be the voltage induced here?
2 volt.
And here?
2
With
volt.
respect to this 2 volt. Now tell me, with this polarity, which diode is forward biased, which is reverse biased?
The upper one is forward bias, lower one is reverse bias.
So current will flow like this? Yes.
Yes, sir.
With this output, this will not conduct. So can I draw? Now I will take ideal diode and draw. Can I draw like this? D1 is conducting. Can I say? देखो बोलो. Negative half cycle. What will be the voltage here?
Minus 2.
Again, let's say 2. 2 volt only, but opposite polarity, right?
Yes.
Here, 4 volt only, but opposite polarity, right?
Yes, sir.
2 volt, opposite polarity. 2 volt, opposite polarity. Now, which diode is forward biased?
D2.
D2. So current will flow like this. Is the current through the load changing its direction?
No, sir.
So will the polarity change?
No, sir.
D2 conducting. Again, D1 conducting. Again, D2 conducting. What is the output you are getting? Full wave rectified output. What is the DC? Area of this is Vm by pi. What will be the area for 2 pi? Full cycle. Twice the area of a half wave rectifier. Clear? This is called as full wave rectifier with center tap transformer. But this is costly. Why?
The two diodes are used.
You have a center tap transformer required to do rectification. Now we can make it a cheaper circuit. How?
Four
This one
diodes.
circuit. Correct.
Just use 4 diodes. So how that circuit looks like? Circuit looks like this. This is the load. This is the AC. This is the output. In the positive half, which two diodes are conducting D1, D2, D3, D4? Bolo.
One D2.
D2 and D4.
D2 and D4.
See, I have already taught you diodes. Now you should answer properly. Which diode is forward bias?
D2 and D4, sir.
D2.
D2 definitely. And
D4.
are you sure?
Yes, sir.
Okay. So whichever is forward bias will conduct. Yes. Yes, because other two are open switches. Yes or no?
Yes, sir.
Now tell me.
D1, D3.
D3, D1.
Current will flow from positive terminal to negative terminal. Clear? Is the direction of current changing?
No, sir.
No.
So the polarity of the voltage will also be same. This
Same.
is a full wave rectifier. How much output?
2 Vm by pi.
But you know here, two diodes are conducting, so the voltage I actually would have to cross how much voltage?
2 Vb.
1.4. है कि नहीं? Since two
Yes, sir.
diodes are conducting in each path, the voltage, the input voltage must cross 1.4 to make both the diodes
Conducting.
cross the
Conducting.
barrier potential. Here in a center tap transformer, only one diode was conducting. So the drop has to be only
0.7 volts.
0.7.
volts. So actually, which is giving you more output voltage? This or that? Center tap.
Center tap, center tap.
Center tap is giving you a little more voltage than this circuit. But it's okay. 0.7 is not so significant. At this cost, at the cost of adding two diodes, you are getting a reasonably good DC output. So normally this circuit is used. Okay. But you want more precision, you go for center tap. Clear? There are other advantages of center tap also. Is the full wave rectifier clear? Circuit clear? This circuit,
Yes, sir.
this circuit, if you don't remember, don't start scratching your head. You can draw it like this also. ठीक है? If you are not able to remember ये डायोड ऐसे जा रहा है, ऐसे जा रहा है, ऐसे, तो ऐसे ऐसे आप याद कर लो. ठीक है? ये भी सर्किट सेम है. ओके, इधर लोड लगा दी. यहाँ पे कौन कंडक्ट करेगा पहले? D1 और
D3.
D3.
in the next half cycle D2 and D4.
D4.
Doesn't matter how you write D1 D2. If अगर आपको पता चल गया कैसे आपको forward bias reverse bias निकालना है, you are able to easily explain the circuit. Clear? Now we are going to discuss SCR. SCR we are also calling it a rectifier, silicon control rectifier. So how it is different from a diode? Let's see. We called this diode as a uncontrolled rectifier. Is it clear why? Can you
Yes, sir.
change the output of this? Can you make it something else other than this?
No,
No,
sir.
sir.
It will always be like this, right? What if I input frequency, I increase it? What will be the effect on the output voltage?
Same, sir.
Same. Are you sure? If I use the frequency of this kind, increase the frequency, will I get the output also same 2 Vm by pi? ये क्वेश्चन पूछा था.
Yes, sir.
Same.
Yes, sir.
Same. Same, not same.
Same, sir, because we are
Same,
integrating
sir.
from pi to 2 pi, sir.
Sorry.
0 से 2 pi इंटीग्रेट कर रहे हैं सर, तो फ्रीक्वेंसी चेंज होगा लेकिन एंगल तो सेम ही रहेगा सर.
सिंपल आंसर है. इसमें कोई भी फ्रीक्वेंसी का टर्म
नहीं है.
नहीं है. सिंपल आंसर, स्ट्रेट फॉरवर्ड आंसर. ठीक है. If I change the RMS value, will the output change?
Yes, sir.
Yes, because Vm will change, output will change. Simple है. Straight forward आंसर बोलना है. ठीक है. ज्यादा घुमा के नहीं बोलना है. Clear?
Yes, sir.
This is the load. We are giving some input at some frequency. This is my circuit. This is a silicon controlled rectifier SCR. Now tell me what will happen. This is the input. Is it forward bias from this time to this time?
Yes, sir.
Yes, it is. If it is forward bias, will it conduct?
No, sir.
No. Why?
No latching current.
No, not latching current.
No gate current.
No gate current given. If gate current is not given, how it will latch?
Yes, sir.
Yes. So I can apply the gate current from which time to which time?
0 to pi.
0 to pi, which is the phase angle also, right? So the phase angle at which this is 0 degree, this is 180 degree. The phase angle at which you will apply the gate signal can be between 0 degree to 180 degree. Is it clear? Because this is the time during which the phase angle during which the SCR is forward bias, correct?
Yes, sir.
So this angle is called firing angle. So how do you define firing angle? It is the phase angle at which the gate signal is or positive gate current pulse is applied to the SCR. Okay. So this is the range in which the firing angle can, be there. This is the ideal range. Practical range is 3 degree to 177 degree. Okay. Clear? Now let us apply the firing angle at alpha 1. I can apply? Is it possible?
Yes, sir.
Yes, sir.
Yes, yes. Now tell me, from 0 degree to alpha 1, is the SCR conducting?
No,
No,
sir.
So is there an output here?
No, sir.
no, sir.
No output. So till alpha 1, no output. Output voltage is 0. At alpha 1, will it start conducting?
Yes, sir.
If it is greater than, sir, latching current.
Yes, it is. It must be, right?
Will conduct.
Latching and holding current value are very, very small. So by this time, it must have crossed, right? Yes or no?
Yes, sir.
You have a resistive load, current and voltage are in phase, right? So by this
Yes, sir.
time, latching current must have crossed. Okay. There is no way it would not have crossed. So it would have crossed at this time. So is it going to conduct?
Yes, sir.
Yes. At this time, let's say the voltage across the input is V1. what will be the output here? V1 only if I ignore the voltage drop across the SCR.
Yes, sir.
Yes, sir.
So can I draw like this? Is it correct?
Yes, sir.
Because
Yes.
because the moment it you stop the gate current, still it will get remain latched. This we discussed. That even if you make the gate current 0, the device is latched, it will keep conducting
Yes, sir.
till it is reverse bias, right? But till here it will
सर
keep.
एक बार
Hmm.
सर सर एक बार ये बता दीजिए कि अल्फा 1 पे ये हमारा वोल्टेज क्यों नहीं आया?
अल्फा 1 पे क्या नहीं आया?
सर
क्या
ये नीचे वाले ग्राफ में हमने वेव
हाँ,
क्यों नहीं लिया अल्फा 1?
अल्फा 1 पे क्या नहीं समझ में आया, क्वेश्चन ढंग से पूछो।
सर अल्फा 1 ये नीचे वाले ग्राफ में है, तो यहाँ तक वेव हमारी नहीं आ रही है ना, यहाँ पे वोल्टेज
क्यों
नहीं आ
आएगी?
रहा है।
क्यों आएगी? यहाँ पे मैं गेट पल्स दे रहा हूँ, तो इसके पहले गेट पल्स ही नहीं है तो एससीआर ऑन है। पूछ रहा हूँ, क्वेश्चन पूछ रहा हूँ। अभी पढ़ा है एससीआर ना?
हाँ सर, वो
मैं गेट पल्स नहीं दिया अभी तक, मेरा गेट पल्स 0 है, 0 है गेट पल्स।
ओके सर,
यहाँ पे गेट पल्स दे रहा हूँ, तो गेट
ठीक,
करंट नहीं दिया है तो एससीआर ऑफ है। एससीआर ऑफ है तो कहाँ से करंट फ्लो करेगा? नहीं करंट फ्लो करेगा तो ड्रॉप कहाँ से आएगा? आउटपुट कहाँ से मिलेगा मुझे?
ओके सर, ओके।
0। जैसे दिया ऑन हुआ, जो भी वोल्टेज है यहाँ पे अपियर होने लगा। दिस इज नाउ एक्टिंग एज अ स्विच। If it is a switch, ideal switch, whatever is the voltage here, same will be the voltage here, right?
Yes, sir.
सारे सेमीकंडक्टर डिवाइसेस में आपको यही सीखना है कि कब स्विच ऑन हो रहा है, कब स्विच ऑफ हो रहा है। ऑन होगा तो जो इनपुट वोल्टेज है, आइडियली हम मैं बोल रहा हूँ, वही आउटपुट वोल्टेज होगा। ऑफ होगा तो जो भी इनपुट वोल्टेज है, आउटपुट वोल्टेज विल बी 0। Entire voltage will come across the switch and it is off. Clear? Now when it goes in the negative cycle, is the SCR forward biased, reverse biased?
Reverse bias.
Reverse.
This is naturally commutated. समझ में आया? नेचुरल कम्यूटेशन। आपको कुछ करना नहीं पड़ा उसको ऑफ करने के लिए, ये अपने आप ऑफ हो गया। इट इज नेचुरली टर्न्ड ऑफ। दिस इज कॉल्ड नेचुरल कम्यूटेशन। In AC circuit, you don't have to do any special thing to turn it off. Automatically, it will turn off. Clear? What will be the voltage?
Mhm.
0. In the next cycle, if I do not apply the gate signal, will it turn on again?
No, sir.
No, sir.
No.
No, sir.
Let's apply it at a lower firing angle. Here I let's say applied it at 110 degree. Let's apply it at 45 degree. So which is greater angle? Alpha 1 or alpha 2?
45 alpha 2.
Alpha 2.
Alpha 2 is greater. What kind of mathematics?
No, sir. No. It will conduct the form
Alpha
of
1 is greater. You have to consider the firing angle within the half cycle, not their absolute value. Okay? Which is greater, alpha 1 or alpha 2?
Alpha 1.
1.
Alpha 1 is greater. I am going to draw the waveform. Tell me if it is correct or not. Is it clear? Is it
Yes,
correct?
sir. Yes, sir.
Now, is this what you are getting is DC or AC?
Sir, DC, sir.
DC.
So this is also converting AC to DC. Can I call this SCR as a rectifier?
Yes.
Yes, sir.
And if I ask you what is the average value, what will you say? Alpha 2 pi Vm sin theta d theta 0 to 2 pi d theta, correct?
Yes, sir.
Integration of minus cos theta alpha 2 pi, correct? Can I say this?
Yes.
Cos alpha minus cos pi this become Vm by 2 pi, this become minus 1 plus cos alpha. So this is the output you are going to get. If your alpha is less, what will be DC value? If alpha is low, cos alpha will be
Sir, increasing
Greater.
more.
cos alpha is a decreasing function, right? So if
Yes.
और वो भी डिपेंड करता है आप अल्फा किस किस रेंज में चेंज कर रहे हो, है ना? ये है पाई, ये है 0, ये है 90, है ना? तो आपको देखना पड़ेगा कि आपका वैल्यू किधर है। लेकिन कहीं भी हो, यहाँ से यहाँ जैसे आप बढ़ोगे, क्या हो रहा है अल्फा का वैल्यू? अल्फा का वैल्यू जैसे जैसे आप बढ़ा रहे हो, कॉस अल्फा
डिक्रीज हो रहा है।
डिक्रीज हो रहा है। कॉस अल्फा डिक्रीज हो रहा है तो डीसी वोल्टेज
डिक्रीज हो रहा है सर।
डिक्रीज होगा सर।
डिक्रीज होगा, राइट? नहीं होगा?
यस सर।
सो आपका एवरेज वैल्यू बढ़ेगा। अगर आप फायरिंग एंगल ज़्यादा रखते हो तो आपको एवरेज वैल्यू, आउटपुट वोल्टेज कम मिलेगा। अगर फायरिंग एंगल कम रखते हैं तो आपको एवरेज वैल्यू और डीसी आउटपुट
ज्यादा मिलेगा सर।
ज़्यादा मिलेगा। दिख रहा है ये फॉर्मूले से?
हाँ सर।
सर ये 0 to α1 जो है वो फायरिंग एंगल है ना सर?
एंगल क्या एक रेंज है होता है या एक वैल्यू होता है?
वैल्यू वैल्यू।
तो रेंज कैसे बोल रहे हो? 0 से α1 एक फायरिंग एंगल है क्या? एंगल बोल रहे हैं ना, एंगल मतलब फेज एंगल है, तो वो एक वैल्यू है ना।
हाँ सर।
तो अगर मैं बोलूंगा 90 डिग्री फेज एंगल, तो आप ऐसा थोड़ी बोलोगे 0 से लेकर 90 डिग्री फेज मेरा फायरिंग एंगल है, ऐसा थोड़ी होता है। 90 डिग्री मेरा फेज एंगल है, 90 डिग्री यही होता है। बेसिक्स नहीं का आपने अटेंड किया है इसलिए ऐसा हो रहा है। Voltage is Vm sin omega t. This is how AC voltage is represented. This omega t, can I call it a phase angle? Because sine is always defined for a theta, right? Yes or no?
Yes.
यस सर।
So this omega t must be a phase angle, right?
हाँ
ये
सर।
बेसिक
यस
में
सर।
पढ़ाया था। So what is time is also can be represented as an angle. This angle is called phase angle in case of AC. This is what we are telling it as what?
फायरिंग एंगल।
Firing angle. So firing angle is nothing but a phase angle. If you know the phase angle, if I tell you phase angle is 90 degree, can you not calculate the time for this? At what time you are giving this?
यस सर।
नहीं निकाल सकते। थीटा को अगर मैं पाई बाय 2 कर दूं और
निकाल
मुझे
सकते
फ्रीक्वेंसी पता है 2 पाई एफ, मान लो 60 हर्ट्ज का है, तो मैं टाइम नहीं निकाल लूंगा? नहीं
हाँ सर
निकलेगा?
निकल जाएगा।
आराम से निकलेगा। 60 इंटू 4, 1/240। नहीं, एक साइकिल कंप्लीट करने में 1/60 सेकेंड, हाफ साइकिल कंडक्ट करने में
1 बाय 120।
1/20, तो 90 डिग्री कंप्लीट करने में
1 बाय 240।
आया ना? इसको निकाल लो कितना मिली सेकेंड्स आता है। सो व्हाट इज फेज एंगल इज नथिंग बट द टाइम, राइट?
ठीक है सर।
ठीक है। सो इसको रेंज मत बोलो, रेंज नहीं है वो। अगर मैं बोल रहा हूँ फायरिंग एंगल मतलब इस टाइम पे, तो ये टाइम कौन कैलकुलेट कर रहा है? हु इज कैलकुलेटिंग दिस टाइम? द माइक्रो कंट्रोलर इज कंट्रोलिंग, राइट? वो प्रोग्राम में फिट है कि इतने टाइम के बाद हर एक टाइम में ये फायरिंग एंगल जनरेट करो। अब आप उस पर कोई चेंज कर दोगे तो फायरिंग एंगल चेंज हो जाएगा। ठीक है। Now, do you see you are able to control the output of a rectifier even if you are not touching the RMS value? Can you change the output voltage?
यस।
एक्सक्यूज मी सर।
Wait a minute. Do you see that we are able to control the rectifier output
यस सर।
unlike a diode? So can I call it a controlled rectifier?
यस
यस सर।
यस सर।
Yes. Okay. Do not break your head over remembering ये कैसे आया वो कैसे आया। आपका मेन काम है समझना कि ये सर्किट कैसे काम कर रहा है। SCR बेसिक ऑपरेशन आपको समझना है। Do not go run after all this mathematics and break your head. Okay. आपको बस जानना है कि ये ऑन कब हो रहा है, ऑफ कब हो रहा है। इतना आपको आ गया तो आपको सर्किट समझ में आएगा। बाकी सब चीज़ मैं एक्स्ट्रा बता रहा हूँ सो दैट इसमें से अगर आपके पास 20% भी रहेगा, यू विल सिट देयर एंड आंसर विथ लॉट ऑफ कॉन्फिडेंस। ओके, दैट्स इट। दिस इज नॉट टू बर्डन you with lot of mathematics. If you can't remember, don't remember. Just formula आपको पता होना चाहिए, basic relation पता होना चाहिए. If I keep the firing angle low, my conduction angle will be higher. My SCR will conduct for a longer time, so I will get the more average value. More average value means more DC output. Clear? So this is a controlled rectifier. It is made up of silicon, so we call it what? Silicon control
Silicon control
rectifier,
rectifier.
or SCR. Clear? Yes, question.
Sir, can you please tell this time relation once again, that how this time is related?
This you missed it. We'll discuss in the basics. I'm not teaching basics right now. When we start the batch, we'll do it. Okay. Why should I waste time of those who have already gone through it? Hmm? You attend a class again in the new batch. We'll do it. Okay. Now, SCR, soft starter. Let's discuss soft starter. Now, soft starter means we want to use a SCR to design a starter which can give what? Which can
Low
reduce?
voltage.
Yeah, which can give reduce voltage to reduce AC
Motor.
voltage to motor during
Startup
Starting
period.
operation.
starting period. What is the starting period defined as? Time taken by the motor to reach 80 to 85% speed. How much is this approximately?
5 seconds.
5 seconds.
5 seconds. So I want to give reduced AC voltage to the motor. Here it is SCR. It can only give DC voltage. So how to make a SCR give AC voltage? Very easy. Put a SCR like this. This will conduct in positive half, this will conduct in negative half. So you will have conduction going on in both the half of the cycle. You will get AC voltage. And since by controlling the firing angle, we can control the output voltage, we can control the AC voltage also. So let's see how we are doing it. Okay. Do you have class after this?
No.
No,
Do
sir.
you- Anybody has class after this?
No,
Yes,
sir.
sir. Yes, sir.
Yes, sir.
Okay. Safety classes. Okay. Okay, just give me 2 minutes. I'll just cover this and then we'll continue this. We'll not finish it today. So I'm going to call these two switches as two SCRs as TA plus and TA minus. Now, is it clear to you that in the positive half cycle, TA plus will conduct? Is it clear?
Yes, sir.
Because it is forward bias. So current will flow in this direction. This will be the output voltage. Let's start with a higher firing angle, alpha 1. So conduction will be like this. Clear? I'm drawing output. In the negative half cycle, can I say this TA minus is forward bias? No? Yes?
Yes, sir.
TA minus, top one.
Yes, sir.
Forward bias, this is reverse bias, so it will automatically turn off. So this is forward bias. Let's apply at the same firing angle, alpha 1. So when it conducts, it will start conducting at this time or this firing angle. So it will conduct from where? Like this. So has the current through the load reversed? Yes, it has. So this will be the output. Just see. Yes, no.
Yes, sir.
So
Yes.
is this AC or DC?
AC.
This is AC. Now, in the next cycle, let's reduce the firing angle. Tell me what will be the output. Will the output be like this?
Yes, sir.
Yes, sir.
हाँ
Now, this is a AC voltage. Now, do you see that I have produced a AC voltage whose RMS value I am able to control by controlling the
Firing.
Firing.
firing angle. So for both the SCR, I am keeping the firing angle same in one cycle. Next cycle, I am changing it. So what it will do, if I calculate the RMS value here, what will be the RMS value? Is it also some kind of area only? RMS value?
Yes.
Because what is RMS value? This only, no? We square it and then we integrate it and then we take a square root. But whatever you do, you are calculating integration. That means it's a area only, right? Yes. So
Yes, sir.
area of this will be greater or area of this will be greater.
Sir, धीरे धीरे increase हो रहा है, sir.
So
Alpha.
So if you decrease the firing angle, can I say the RMS value also increases, just like your DC output average value?
Yes, sir.
Yes,
yes
sir.
So similar relationship is there. So if I want to, let's say, find out the RMS value in the first cycle, can I draw and with a line and show it is this value? You can calculate area and say this is the entire, for this entire cycle, this is the RMS value. Can I say?
Yes, sir.
And for the next cycle, can I say it will be a little higher?
Yes, sir.
Yes, sir.
I will
yes
further decrease it in the next cycle. It will become
Higher.
More.
like this, like this. I can keep doing and I will do this till what time?
Till
80 to 85%.
till
Till
440.
5 seconds. Till 5 seconds I can do during the starting period, right? I can connect this. I can, instead of this load, I can connect a single phase motor here and run it like this, right? No.
Yes, sir.
In 1 second, how many cycles?
60.
5 seconds, how much cycle?
300.
300.
You will not even see the steps. It will be happening like this. Yes.
Yes.
Yes, sir.
Is this the waveform that is going inside your motor? No.
No, it is a voltage.
Your waveform is this. This is the waveform. This is only showing you how the RMS value is ramping up. Normally, the RMS value of the input will remain fixed, right? Yes or no? Why it is fixed? I am not changing the waveform shape, right? So this is fixed at what value? Vm by root 2. But here the RMS value is ramping because we are we are starting with a higher firing angle, and as the cycle passes, we are reducing the firing angle. So the RMS value is
increase
ramping
Increase
up.
gradually.
It is increasing gradually rather than increasing suddenly in a star delta or a auto transformer starter. Is it clear? So
Yes.
this has a certain advantage. What is the exact advantage? We will see in the next class tomorrow. Okay, is it clear?
Yes.
Okay,
sir.
this is only for a single phase. We will see the circuit, three-phase circuit tomorrow. But this is the waveform. Okay, if you are asked in exam, draw the output waveform of a soft starter. This you can say this is for A phase, this is for B phase. Let me just draw the circuit also. So for three phase, this will be the circuit. This is VA, this is VA dash. Similarly, you can just repeat it for the two other phases. Then this can go. This is your overload relay. This is your motor connected in delta. Okay. This can be a main contactor. So this will close when you press the what? Start push button. You need a gate control circuit to trigger the what? These SCRs. These SCRs you can mark it TA plus, TA minus, TB plus, TB minus, TC plus, TC minus. Once the starting period is over, you want to what? Bypass the
SCR sir.
SCR circuit and connect the full rated voltage to the motor. Okay, so this is called your bypass contactor. KB. Both this KB and KM are operated by a relay current driven by the microcontroller or gate control circuit. There is a microcontroller here which is generating relay current and operating it when you press start or stop, whatever. Clear? So this is called as bypass contactor. This is overload relay for thermal overload protection of your motor. Clear? This is a soft start. Chalo, we'll stop here. We'll continue in the next class.
Thank you, sir.
Yes, sir.
Go through it. Please read Duty Hall and Mac George. Whatever we are covering is also given there in some form. Please read it and come tomorrow. We can discuss this again. So tomorrow is an important class. We'll finish synchronous motor, whatever is remaining. And yeah, the soft starter again we can look at advantages, disadvantage. Finish auto transformer starter, star delta starter. Star delta is remaining for class 4 or class 2? I think star delta is we
Class
finished
4.
for class 4 we did
No,
star delta.
No, sir. Class 4 remaining, sir.
No, class 4 it is remaining. Okay, I think we'll have a separate class for you guys tomorrow, but this 2-hour class will also continue for you. Okay, so we'll cover your star delta separate. Sorry, DOL भी बता देंगे. चलो, okay, we'll do it.
Thank you, sir.
Thank you.
Thank you, sir.
thank you, sir.